So for 7.2a, we are splitting it up into 2a and 2b. Today we're just going to be simplifying the complex fractions. So first we need to figure out, we need to do a couple definitions and write down some steps. First thing is finding the least common denominator. We call that the LCD. Or we also call it the least common multiple. They're the same thing. Okay? So LCD or LCM, they are the same thing. The definition is that it is the smallest number that all terms can divide into evenly. So there are bigger ones, but we are looking for the smallest one. My steps to finding the LCD. Step 1, I am going to factor if needed. If they share the same factor, we only need one. So if your denominators share the same factor, you only need one of them. Anything not in common, you also need. So, for example, say that there is two denominators and they both have x in them. You don't have to write x squared, you only need to use x. Okay? And then last thing is we are going to multiply everything together. And we're going to practice this before we actually start any problems. Are going to practice this right now. So I want you to find the LCM of 5 and 45. So what we're going to do is a lot of people get LCM confused with greatest common factor. We're not looking for factors, we're looking for multiples. So what number does both 5 and 45 go into? The smallest one.
5.
45. 45 divides into 45, and 5 divides into 45. So we are looking for the smallest one that both divide into. So then our next one would be 3 and x.
3x.
What number does both 3 and x go into?
3x.
3x. Okay, so what about x, y, and y to the second? What's the smallest thing that both of those terms go into? X, y, and y is to what power? The second. Think about it. Y squared goes into xy squared, and xy goes into xy squared. We don't have to put a y to the third because it's not the smallest one. Okay?
Okay.
All right, so we are going to use the LCM to take everything a little bit further. I'm going to erase that really quick so that I can scroll down. So we're going to use this to simplify complex fractions.
Oh, God.
Okay? So to simplify complex fractions, step 1. You want to multiply every term by the LCD to get rid of the fractions. So we're going to have fractions and fractions, which we don't want. So we're going to use the LCM to get rid of the fractions. We want to combine like terms if possible. Combining like terms is our favorite thing to do, right? And then simplify. All right, so step 1 said we need to multiply every term by the LCD. So look at all of our denominators first.
5.
What is the LCD?
5.
5. So what we're going to do is multiply every single term by 5. And this is okay because whatever we're doing to the top, we're also doing to the bottom. So it's okay that we're doing that. So multiply every term by the LCD of 5. So take a look. This is 5 times x over 5. Does anything reduce? The 5's reduce. Does anything reduce in the denominator? The 5's again. So what am I left with?
X over
X over x plus 5x squared. Well, I'm not done simplifying.
The X's don't because it's attached to it.
It's attached by that.
The x's, you are right. The x's here do not cancel because they are attached. But what do you notice about the denominator?
Oh, God.
It has a GCF of x. So we have x over x times 1 plus 5x. So we pull out the GCF. Now we are allowed to cancel. So now you can cancel the 5's, or the x's. So that's going to give me what in the numerator? 1. And what in the denominator? 1 plus 5x. We're just simplifying. We are not solving, so you are done.
It still looks kind of scary.
So example 2. X over 3 minus 6. All over 10 plus 4 over x. Now we only need to look at the denominators to find the LCD. So if I'm only looking at the denominators, 3 and x, what is my LCD? 3x. So multiply everything by 3x. What property am I actually using when I multiply everything by the same thing?
Wait, why are you multiplying everything by 3x?
We're multiplying the top by 3x and the bottom by 3x. But when I use distributive property, it distributes a 3x to each term, right?
But how did you get 3x?
It's our LCD,
It's an LCD.
least common denominator.
Dude, stay with
Oh, I
us.
see it.
Yeah, there you go.
Okay, so now we can actually start canceling. Look right here, 3x and x over 3. What reduces? 3 and 3. Can I reduce x and x?
No.
No, it's all in the numerator. That doesn't reduce. 6 and 3x, does anything reduce there?
Yes.
No, because it's not a fraction. 3x and 10, anything reduce?
No.
No. What about x and 3x?
Yes.
The x is reduced. So that leaves me with, we multiply whatever's left over. So x times x gives me x squared minus 18x all over 30x. Plus 12. Okay, we are obviously not done, right? I have some GCFs in there. What is the GCF in the numerator? X, so factor out the x. That leaves me with x minus 18. I also have a GCF in the denominator. What is that?
3.
It's 3. So pull out the... nope, there's something bigger. 6. So that gives me 5x plus 2. Okay, does anything reduce? No. So we are done. But I want you to make sure you get used to factoring just to check that we caught everything that we could. That's basically everything. Let's try one more. Okay. So, example 3. Okay, example 3. 1 plus 1 over y all over x plus x over y.
LCD is
What's the
y.
LCD?
Y.
Y. So multiply everything by y. Card.
Y. No, Y. LCD is badass.
Oh, when he does that on the subject where they look at him
Y
like, just leave.
plus
What's this?
Okay. So we multiply everything by y.
Those are some good looking Y's.
Yeah, they're not that good.
Yeah,
I know.
wow.
Okay. Y times 1. Does anything reduce there? No. 1 over y times y. Does anything reduce there? Yes, the y's. Y times x, anything reduced? Nope. X over y times y, anything reduced there? The y's again. So we are left with y plus 1 all over xy plus x. And I'm finished, right?
Yeah. Oh, can you take? I thought you couldn't take the Y.
You can take the y out on the bottom. Wait, no.
What do you guys
Take
see?
the x out on the bottom.
There's a GCF in the denominator of what? Of x. So y plus 1 is in the numerator. All over x times y plus 1.
You cancel y.
You can't just pull y because it's attached by addition. So you can't reduce that. You can only reduce the whole thing. So notice how this y plus 1 and y plus 1 are exactly the same. You can reduce those. So what is in the numerator?
1.
1 all over x. And that's your answer.
Oh.